Hello students, welcome back. Welcome to the chemistry class. Today we are discussing a very important chapter for JEE Mains in advance. Chapter is chemical bonding. This chapter is highly recommendable for JEE syllabus, and in this chapter we'll discuss some of the important facts and some of the important properties of chemical bond. And to understand this chapter, we have to follow this flow chart. I'll explain it to you. Yeah, we have this flow chart. We have to follow this flow chart in this entire lecture, and this lecture would be completely uh, uh, explanatory on the basis of the given flow chart you can see on your screens. And in this chapter we have to learn generally 80% of the facts of this chapter, and uh, uh, I'll give you some of the examples with the help of diagrams, with the help of some molecules. Okay, so without wasting any time, let's discuss. Okay, so let me zoom it to you. Yeah, now first of all we have to discuss what a, what is the meaning of chemical bond. Okay, now the definition of chemical bond is given to you in this flowchart itself. As you can see here, chemical bond is attractive forces which holds the various chemical constituents together in a different chemical species. Okay, whenever more than one atoms or species combine together, attractive force generates, and this kind of attraction force is called chemical bond. Okay, on the basis of attraction force, we can say that chemical bonds are divided into three major types. There are many types of chemical bond, but three types are very important for your syllabus. Okay, now first one is covalent bond. Second one is ionic bond, and third one is coordinate bond. Okay, now covalent bond is a chemical bond formed between two atoms by mutual sharing of electrons. Okay, mutual sharing of electrons between them to complete their octet. Now what is the meaning of octet? If any atom wants to stabilize itself, listen carefully, if any atom wants to stabilize itself, it has to complete its octet. It means in its outermost shell in its outermost shell total 8 electrons must be present. Okay, so the presence of 8 electrons in the outermost shell of any atom except noble gases, okay, then this condition is called octet condition, right? So why elements or atoms are sharing the electrons to complete the octet? So if bond is formed by sharing of electrons, then this kind of bond is called covalent bond. For example, hydrogen has one electron, other hydrogen has also one electron. So if they both shares the electron, this condition is called covalent bonding, where we can see H bond H condition. Okay, now second one is ionic bond. Ionic bond is formed between the ions, that is cation and anion, positive ion and negative ions, right? The best example of ionic bond is, I'm giving the example, that is NaCl. This is a table salt, uh, and this form is formed by attraction between Na plus ions and Cl minus ions. You can see here Na plus is cation and Cl minus is anion. Okay, and the definition is also written here: the chemical bond formed by complete transfer of electron from one atom to another atom. Okay, so initially Na is like Na dot, and Cl is look like Cl7 dot. Okay, so due to the metallic character of, or due to the electropositive nature of sodium, it donates complete electron from his shell to the shell of Cl. So Na becomes Na plus due to the donation of electron, and Cl becomes minus due to the accept of electron, okay, from sodium. Now the third type is coordinate bond. In coordinate bond, a chemical bond formed by donation of two electrons from one atom to another to complete their octet. Okay, it means if you have NH3 ammonia and another molecule is BF3, boron trifluoride, and BF3 has electron deficiency. So to make the bond, nitrogen of ammonia donates its complete lone pair to the BF3, and you can see the following. Let me write properly. You can see the following type of bond. So this kind of bond, which can be represented by arrow, then this is called coordinate bond, where one atom donates its lone pair to the other atom. Okay. So this is the information about chemical bond and the type of chemical bond, major type of chemical bonds. Okay. Now after this, we have to discuss. Yeah, we have to discuss this section, that is chemical bonding. To explain chemical bonding, two scientists were there. One of them was Lewis, and another one is Kossel. That's why the theory of chemical bond is also called Kossel-Lewis theory, right? So we have some pointers here. Yeah, Kossel-Lewis approach to chemical bond. The first point, remember all these points. These points are very important for your problem solving in JEE Mains, right? So first point is Lewis pictured the atom as a positive charge kernel. Remember that in NaCl, NaCl is an ionic bond, right? NaCl, when forms bond Na combined with Cl, where Na shows positive charge. So all kind of positive charged particles or cations are called kernel. Okay, students are confused about the kernel, so I'm explaining that kernel is all about the positively charged particles in a ionic bonded molecule. Okay, so kernel and the overall, so and the outer shell accommodates a maximum of 8 electrons. Okay, so if any atom is showing positive charge, but it has to complete its octet by the filling of 8 electrons. This is the concept of Kossel and Lewis. Second point, Lewis postulated that atoms achieve the stable octet when linked by chemical bond. Okay, so due to the formation of chemical bond, all type of atoms or kernel, we can say, they shows stable octet. If octet is not stable, then bond will not be formed. Okay. Third, Kossel gave following facts. One of the scientists, Kossel, gave following facts. In the periodic table, the first fact is, in the periodic table, highly electronegative halogens and highly electropositive alkyls separated by noble gases. Electronegative halogens you can see in the periodic table, that is fluorine, chlorine, bromine, iodine. Okay, and electropositive alkali should be lithium, sodium, potassium, rubidium, and cesium. Okay, so electropositive halogens and electronegative halogens are separated by noble gases. Do you know the noble gases? Noble gases are helium, neon, argon, krypton, xenon, and radon. Okay. Next fact is, formation of negative ion form a halogen atom and a positive ion form a alkali metal is associated with a gain and loss of electron by respective atom. Every time electropositive atom will produce electron from its outermost shell, and electronegative element always gains electron from that electron positive element. Okay, remember that electropositive will release the electron, electronegative will gain the electron. Okay, this is very important fact which you should remember. Next point is, negative and positive ions formed attain noble gas electron configuration. If any species is taking out the electron, okay, and if another species is gaining the electron, the complete phenomena is stability, to gain stability. Okay, sodium is releasing electron. Why? Because it is completing its octet. Okay, and if chlorine is getting taking electron from the sodium for stability, for completing its octet. Okay, so all the phenomena are happening here due to the complete of octet, due to the stabilize all the species and itself. Okay, now A very important rule was given by Lewis, that is called octet rule. As you can see here, atoms can combine either by transfer of valence electrons from one atom to another, or by sharing of valence electrons to complete octet in their valence shells. Okay, what do you mean by valence shell? Every atom has outermost shell. Remember that every atom has outermost shell, and in outermost shell, presence of total number of electron is called valence shell. Okay, and those electrons are called valence electrons. A place where valence electrons are present are called valence shells, and in valence shells, total number of valence electrons are present. Okay, so in octet rule, if any element or if any atom wants to stabilize itself, it has to complete its valence shell with valence electron with the number of 8. This is called octet rule. Okay, I'm giving you one example. Suppose I have oxygen. The atomic number of oxygen is 6. It means it has 6 electrons in its outermost shell, but it is not stable. To gain stability, it has to gain 2 electrons from the surrounding or from the other species, right? So after gaining 2 electrons, oxygen becomes 6 to 8. Now this oxygen atom is stable because it has 8 electron in its outermost shell. Okay, now other thing is, Lewis dot structure provide a picture of bonding in molecules and ions in terms of shared pair of electrons and the octet rule. Okay, so whenever we draw the Lewis dot structure, the octet rule phenomena is very important and very essential for draw any type of structures. Okay, agla, next one is how to write a Lewis dot structure. Okay, okay, so we were on the topic how to write a Lewis dot structure. To write a Lewis dot structure, we have to know how many valence electrons are present in any atom or in any molecule, and which element required to gain stability by completing the octet. Okay, so these are following steps prescribed by Lewis. Step 1 is add a valence electron of the combining atom to obtain the total number of electrons. As I said earlier, we have to know how many valence electrons are present in the valence shell of any element, right? Step 2, for anions, each negative charge means addition of one electron. This is very important. In maths, negative means loss, but in chemistry, negative means gain of gain of whom? Gain of electron. Okay. For cations, each positive charge means subtraction of one electron. Anions means the meaning of anion is gain of electron, and meaning of cation is loss of electron. Okay, from total number of valence electrons. Okay. Step 3, write chemical symbol of combining atoms. Whatever the atom is, we should know the chemical symbol. For example, I'm telling you about the potassium, so I will write K. If I'm uh, 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 explaining about the bromine, so we should know Br. Okay, so these chemical symbols are very important to write a chemical equation or chemical formula for any compound. Okay. Step 4, least electronegative atom occupies central position. This is very important. Suppose I will tell you the compound of calcium carbonate. So the formula of calcium carbonate is CaCO3. CaCO3. Now the main problem is which element or which atom is central atom having the least quantity. Okay, metals are not uh, uh, metals are not central atoms. uh, they can't be a central atom, so the central atom should be non-metallic. So calcium is neglected. We have carbon and oxygen. The least number of atom is of carbon, so carbon should be your central atom. Okay, another example I'm taking here, that is H3PO4. All the elements are non-metals. Okay, now observe that which atom or element has least number, that is phosphorus, no doubt. So phosphorus should be your central atom. Okay, now step 5, after accounting for shared pair of electrons, remaining are either utilized for multiple bonding or remains as lone pair. After accounting for shared pair of electrons, remaining are either utilized by multiple bonds or yes. Whenever atoms or elements combine together with certain amount of bonds, remaining bonds should be multiple. It means if carbon and oxygen already combined, but still there is a possibility of formation of one bond to satisfy the density of electron, so one more bond can be formed. If still both the elements are not satisfied, one more bond can be formed. Okay, so this is very important, you should know this fact. There's a very important concept here, that is formal charge. What do you mean by formal charge? Formal charge is a method to explain the partial positive or partial negative charge in any molecule. For example, suppose we have ozone. The formula of ozone is O3. The structure of ozone is look like this. Okay, now each of the oxygen atom will show different kind of formal charge. The central atom should be +1, right hand side atom should be -1, and the left hand side atom should be 0. Okay, so presence of partial charges in any atom in a molecule is called formal charge, and we can calculate the formal charge with the help of following formula, that is total number of valence electrons. I'm writing a very shortcut formula for you to calculate the formal charge. This is important, no doubt, but to remember that I'm giving you one example. That is formal charge is equals to total number of valence electrons in the central atom or in the experimental atom minus total number of lone pair electrons. If suppose that atom contains 2 lone pairs, it means 4 electrons, minus half 1 by 2 into total number of shared pair of electrons. Suppose that atom is shared atom is formed 2 bonds, and one bond is formed by 2 electrons, so 2 bond will be 4, so 1 by 2 into 4. Okay, so this is the shortcut formula for formal charge. You can remember from your own side, you can take the screenshot, you can take the notes, you can mention this in your notes, but this formula is very important for calculating formal charges. Okay, and this is the larger formula you can see here. You can relate that both will be same. Now after the octet rule, some limitations were also there, and these limitations are: number one, shows 3 type of exceptions: incomplete octet of central atom, or electron molecules, and expanded octet. In many molecules, many scientists observed that some of the molecules are not following the octet rule. Okay, they have it means they are not following the octet rule, but they are stable. For example, uh, I'm giving you 3 major examples. Number one, BeCl2. Number two, number two is uh, NH3. Number three, H2SO4. Okay, now all the three molecules are exceptions of octet rule, because first molecule is showing incomplete octet. The central atom is beryllium, no doubt, but beryllium do not have the 8 electrons in its outermost shell, but it's stable. Okay, so these 3 examples are very important, where incomplete octet are present, odd electron system molecule, right, and expanded octet. Suppose the third example, H2SO4, the central atom is sulfur. Sulfur is stable, or any other atom is stable if 8 electrons are present, but sulfur has more than 8 electrons, but still it is stable. Okay, so these exceptions were not explained by Lewis, and that's why octet rule was questioned at that time. Okay, second, does not account for all the shape of molecules. With the help of octet rule, we cannot find the stable shape of any molecule. This is the second limitation, which is the major limitation at that time. Third, fails to explain stability of molecules. As I told you earlier, some elements are having very less amount of electron, or less than octet, but still they are stable, so that the stability of that molecule uh, uh, was not explained by Lewis and other scientists. Now, a very important bond is there, that is hydrogen bond. Okay, now first of all I'll tell you the definition of hydrogen bond, as written here also: formed when the negative end of one molecule attracts with positive end of other. Okay, or we can say that the attraction force between hydrogen atom, compulsorily hydrogen atom, and other electronegative species. Suppose I'm taking here the example of HF, hydrogen fluoride. It is an acid, right? So in hydrogen fluoride, hydrogen is there and fluorine is there. Fluorine is electronegative in nature, so fluorine can attract hydrogen of other HF also. So we can explain the H bonding like this: HF, HF. Okay, so fluorine of first molecule attracts hydrogen of other molecule, like this. So this kind of bond is called hydrogen bond. Okay, now hydrogen bond is of two types also: intermolecular and intramolecular. Intermolecular between two different molecules or same or different substances. If we have two different molecules and both the molecules are forming the hydrogen bond, then it should be intermolecular. But if we have only one molecule and atoms of that one molecule are forming a H bond, then it should be called intramolecular H bonding. Okay, so this is very important, you should remember this. So I hope you are getting my point. We have discussed two important facts today. Now third one should be our hybridization. Okay, now what is the meaning of hybridization? The third subtopic is hybridization. Hybridization is uh, we can say it in a very simple manner. It means an atom contains more than one orbitals. Okay, electrons are always present in a specific or we can say three-dimensional area, three-dimensional place called orbitals. So electrons are always present in orbitals, and if orbitals have different energies, different shapes, and if those orbitals are combining together, and producing orbitals having same energy and same shape, then this phenomena is called hybridization. I have a one picture image, I can explain you with that. uh, uh, yeah, so in this picture you can see here we have s orbital, we have 3p orbitals. So 1s and 3p, 1s and 3p should be 4 orbitals, right? So whenever one s orbital and 3p orbitals are combining together, they'll produce same amount of orbitals having same energy and same shape. Okay, so after the combining or mixing of 1s and 3p, I need to take same orbitals four same orbitals with energy and shape, right? So look at this: 1, 2, 3 and 4. So I can observe, I'm observing here 4 orbitals having same energy, same shape, okay, and same type of properties. So this condition or phenomena is called hybridization. And after that a molecule can form its structure, its shape, and molecule stabilize itself in a normal temperature or normal conditions. Okay, so this phenomena is called hybridization. You have to remember this. And we have some of the examples here. You should learn this from your own side. Due to the hybridization, or we can say mixing of orbitals, due to the mixing of orbitals we can obtain following type of molecules, that is ab2, ab3, ab4, ab5, ab6, ab2e, ab2e2, ab4e, ab3e2. Okay, ab5e, ab4e2, right? So these molecules are formed, and ab3e we have missed. Okay, so these kind of molecules are forming due to the mixing of a atom and b atom. When various amount of atom A and atom B are mixing together, they are forming different type of molecules having different shape, different geometry, different properties. Okay, so please remember all these things. These are very important for hybridization. Okay, now other important thing is, after the hybridization we should know, that is bond parameters. Whenever a molecule, whenever not a molecule, whenever atoms combines together or mix together, they are forming molecules. Okay, and these molecules are highly stable. But after the formation of molecule, we can see some of the some bond properties. Okay, uh, and these bond properties can be segregated into following types: bond length, bond angle, bond enthalpy, bond order, resonance structure, and dipole moment. Okay, now what is the meaning of bond length? Bond length means if A and B is forming bond, now what is the length of this bond? It's called bond length. We can say that equilibrium distance between the nuclei of two bonded atoms in a molecule. If a bonded atom is A, bonded atom of B, and both the atoms have their own nuclei, the distance between that those nuclei is called bond length. Okay. Second, bond angle. Suppose A is combining with this B and second B. Now, what is the bond angle between AB? So this is called theta, and theta is called bond length. Bond angle. Okay, angle between orbitals containing bonding electron pairs around central atom in a molecular complex ion. Okay, you can see here the angle here also. BAB in AB2 or AB2 molecule, BAB bond angle has 180 degree. Okay, so bond angle is very important for the calculation of properties of any molecule. Now, bond enthalpy, how much energy is required to break that bond? Okay, if you are providing energy, then how much energy you have consumed, you have used to break any kind of bond is called bond enthalpy. Okay, amount of energy required to break 1 mole of bond of a particular type between two atoms. Okay, simple definitions you should remember from your side. Bond order, how many bonds are present between two atoms? For example, suppose it's a very simple definition: HH, we have N2, we have O2. The bond order of HS is 1, because only one bond is there. Between both the nitrogen, 3 bonds are there, and between both the oxygen, 2 bonds are there. So all these values are called bond order. It means how many bonds are present between two atoms. The definition is number of bonds between the two atoms of a molecule. Okay, now 5, resonance structures. The meaning of resonance is shifting of lone pairs or pi bond. For example, suppose I'm giving a very simple example here. Suppose we have carbonate CO3 2 minus. So O double bond C, single bond O minus, and single bond O minus. Okay. The meaning of minus is lone pair. No doubt is here. Okay. Right. Now, lone pairs are very unstable in nature. So the lone pair of oxygen will shift it towards the carbon, but carbon has limitation to for making the 4 bonds only, right? So whenever this lone pair shifted towards the carbon will break the bond with oxygen like this, and you can obtain the other structure: O minus, single bond C, single bond O minus, double bond O. Okay, so this kind of shifting of lone pairs, this kind of shifting of lone pair and pi bond or pi electrons is called resonance structures. Okay, the best example of resonance is benzene. I hope you know that. A set of 2 or more Lewis structures that collectively describe the electronic bonding or a single polyatomic species. Okay, now uh, 6 is dipole moment. The meaning of dipole moment is the partial charges due to the electronegativity of any atom. Suppose I'm rubbing this. Let me give you an example. Suppose I have NF3. The structure of the open structure of NF3 is look like this: one lone pair on nitrogen. Now you know that the electronegativity of fluorine is more than nitrogen. So obviously the electron density will shift towards the fluorine like this. Okay, It means electron density of nitrogen is uniformly shifting towards the fluorine because fluorine has more electronegativity than nitrogen. Okay, so this kind of phenomena is called dipole moment because element or atom uh, uh, which accepting the electron density towards itself will show delta negative, an atom or element which is providing the electron density towards the more electronegative species will be called delta positive. Okay, so dipole moment is a very special weapon, we can say, for calculating the partial positive and partial negative charges, or we can say polarity. If you want to find the polarity in any kind of molecule, then we should use the weapon dipole moment. And to explain dipole moment, we can uh, uh, we can learn the very simple formula, that is mu is equals to q into r, q exhibiting the charge and r exhibiting the distance. Okay, or the definition should be product of the magnitude of the charge and distance between center of positive and negative charge. Okay, so you can eliminate the definition also, but you can learn the formula, that is mu is equals to q into r. Okay, where q is charge and r is distance between both the atoms. Okay, now after the bond parameters, we have a very special theory called VSEPR theory. The full name of VSEPR theory is valence shell electron pair repulsion theory. Okay, uh, yeah. Now, what are the postulates of valence shell electron pair repulsion theory? Before reading the postulates, I will tell you a very simple thing. I am already told you that for stability of any atom, uh, a bond is necessary. If any atom wants to stabilize itself in a free atmosphere, in a free environment, the chemical bond, or we can say the attraction forces between two atoms, same or different, is necessary, right? So VSEPR theory says for stability every atom forms bond, right? But after the formation of bond, we can easily analyze, we can easily calculate or analyze or observe what we can observe: the shape, we can observe the geometry, we can observe the hybridization. We have read this earlier, right? We can calculate the magnetic moment, we can calculate the magnetic properties, that a molecule is paramagnetic, diamagnetic, okay, insulator, something like this. Okay, so these kind of properties we can easily explain with the help of VSEPR theory. Scientists earlier used this theory to calculate all these properties because after the formation of a molecule, it exhibits different kind of properties in in chemical reactions. So before performing any chemical reaction, we have to know all kind of properties of that molecule which we have to use in the chemical reaction. Okay, so VSEPR theory is another very unique example, or a very unique weapon, we can say, method, we can say, to uh, know the stable molecule in a very well manner. Okay, so before wasting any time, let's begin with the postulates. First postulate is shape of molecule depends upon the number of valence shell electron pairs around central atom. Okay, this is very simple thing, no need to explanation. Pairs of electron in the valence shell repel one another. This is obviously electrons are negative charge, so whenever both the electrons are close together and both have the same charges, they will repel each other. Okay, and due to that repulsion, geometry or shape can be formed. Third, these pairs of electrons tends to occupy such position in space that minimize the repulsion. Okay, after the repulsion, the molecule tries to stabilize itself where repulsion is minimized. Fourth, the valence shell is taken as a sphere with electron pairs localizing on spherical surface at maximum distance from one another. It's a very obvious thing. A multiple bond is treated as if it is a single electron pair and the two or three electron pairs of multiple bonds are treated as single super pair. It's obvious thing. When one or more resonance structure can be represented, a molecule VSEPR model is applicable. It is also an obvious thing. Decreased order of repulsion. Yeah, this is a very important thing. Many questions were there on the basis on this topic. The meaning of LP is lone pair, and the meaning of BP is bond pair. Okay, so very this is a very confusing thing among the students. What is the relation between lone pair and bond pair? Okay, lone pairs are free electrons. I'm giving you one example. In NH3, I'm opening this. Nitrogen has three attached hydrogen with one lone pair. Okay, now we have two free electrons. So these two free electrons are called lone pairs, and this bond is called bond pair. And to form this bond, two electrons has been used. Okay, now what is the relation between both of them? Is lone pair have also electrons, but it isn't free in nature. But bond pairs are those electrons which are bonded, okay, or which are consumed, which are used for connecting two different species or two different atoms. Okay, so uh, electrons which are free will show more repulsion, and electrons which are bonded will show less repulsion. That's why lone pair repulsion will be higher than bond pair repulsion. Okay, but there's a middle state. Sometimes lone pair and bond pairs are also there, so lone pair will obviously will show more repulsion than bond pair. So this order is very important for you, so you should remember from your own side. Okay, so after the valence electron repulsion theory, we have a very another example, important example. Not so important, but it is important. We should know the elementary idea of valence bond theory, that is called VBD theory. This theory was given by Linus Pauling, as you can see here. Yeah, that's why it is called Pauling theory also. So given by Pauling, it explains that a covalent bond is formed between two atoms by overlapping of half-filled valence orbitals, each of which contains one unpaired electron. It means this is a very simple theory. I'll tell you the crux of this theory. Suppose we have orbital like this, having one electron, and we have another orbital like this, having one electron. So what VBT says, VBT is saying if we have orbitals having one electron in each, suppose we have two orbitals, as I drawn in the on the screen, you can see here. So if any orbital has unpaired electron or single electron in its orbital shell, then both are eligible for to form a bond by overlapping. And how will they overlap? They will simply overlap together like this. Suppose uh, this is an orbital, this is another orbital, so they will overlap like this, okay, or we can say like this. Okay, so this is orbital A, this is orbital B, and after the overlapping they will combine together like this. Okay, and if this is A, if this is B, the bond will look like this. Okay, so please remember that whenever we are learning the VBT theory, VBT is explaining only one thing, that is covalent bond will be formed after the overlapping of those orbitals having at least one unpaired electron in their outermost shell. Okay, so this is a very important thing. We should remember this from our side. Okay, now orbital overlap concept. What is the meaning of orbital overlap concept? Formation of covalent bond result by pairing of electron in valence shell with opposite spins. Each orbital contains two electrons, and both the electrons must have opposite spin. If any electron is showing anti-clockwise direction spin, then other one will show clockwise direction. So any orbital or any shell having two opposite spin will be the most stable shell with respect to electronic spin. Okay, now types of overlapping. Due to the overlapping, two type of bonds are formed: sigma bond and pi bond. Sigma bond will be formed by the head-to-head overlapping or linear overlapping, we can say. Suppose my two fingers are the two different orbitals, so if they are combining like this, they will be sigma bond. The result will be sigma bond. And for pi bond, suppose I have again two fingers, but they are not overlapping like this, they are overlapping like this is called partial overlapping, and after the partial overlapping we can obtain the pi bond also. Okay, so by the overlapping we can expect two types of bonding only, that is sigma bond and pi bond. We have discussed the hybridization. Okay, so we are now discussing that. Yes, types of hybridization is very important: sp, sp2 and sp3. In sp 1s and 1p is mixing together. In sp2, 1s and 2p orbitals are overlapping. In sp3, 1s and 3p orbitals are overlapping. Okay, earlier I have uh, shown you the diagram with example. Let me show you again. Yeah, so I have that. This is example of sp3 hybridization. You can see here 1s and 3p. Okay, 1s and 3p, 4 orbitals. This is a perfect, this is an example of formation of methane, that is CH4, methane. Okay, so please remember that. Yeah. uh, yeah, after the formation of different kind of molecules, uh, atomic orbitals were vanished, and only molecular orbitals can be formed. So molecular orbitals are of two types, that is bonding molecular orbitals BMO and anti-bonding molecular orbitals ABMO. Okay, bonding molecular orbitals will be formed after the addition of atomic orbitals, and anti-bonding molecular orbitals will be formed after the subtraction of atomic orbitals. Okay, so suppose we have this kind of orbital, and if we are adding this, it should be bonding, and if we are subtracting this, plus and minus, it should be your anti-bonding. Okay, so we have discussed most of the things. Yeah, one important thing we have missed: energy required to completely separate 1 mole of a solid ionic compound into gases constitute ions is called lattice energy. Okay, so we should know the lattice enthalpy. This is a very important thing. The meaning of lattice enthalpy is total amount of energy is required or is consumed to break the lattice of any molecule, any ionic molecule, sorry. Suppose uh, NaCl, we know that NaCl is always stabilized itself in a crystal form, so to form that crystal, all the sodium and chlorine ions, Na ions and Cl ions, are arranged themselves in regular pattern, and this pattern is called lattice. To break that lattice, we have to use minimum amount of energy to break the bond between Na and Cl. Okay, so after the break of bond, lattice will automatically break. So minimum amount of energy required to break the lattice of any crystal of a ionic bonded molecule is called lattice enthalpy. Okay, so this is a very simpler definition you should know from your own side. Now after this, we have discussed major things in this. Yeah, yeah. The last thing is, last topic of this lecture is molecular orbital theory. We can say MOT theory. This theory was firstly proposed by Hunts and Mulliken, widely explained by Hunts and Mulliken. That's why this theory is also called Hunts and Mulliken theory. I'm writing the name of the scientist. Very important. Hunts and Mulliken. Hunts and Mulliken. Okay. Now, this theory is very simple. Before reading the postulate, I'll explain you in a very simple manner. Uh, MOT theory says if any atom wants to form a molecule, then all the orbitals are present in an atom is called atomic orbitals. So those atomic orbitals has to mix together to form molecular orbitals. It means without forming a molecular orbital, formation of molecule is not possible. Or in a short way, we can say whenever atomic orbitals combine together, they will form molecular orbitals, and those molecular orbitals are eligible to form a stable molecule. This theory is most accepted in the chemical bonding branch, because this uh, this theory still has no exceptions. Okay, so let's read some postulates. Now, number one, electrons in a molecule are present in a various molecular orbitals as electrons are present in atomic orbitals. As I have told you earlier, when atomic orbitals combine together to form molecular orbital, all the electrons transferred from atomic orbital to molecular orbital. Okay, the amount of the amount of electrons, electron will not be changed after the formation of molecular orbitals. Okay, number two, atomic orbitals of comparable energies and proper symmetry combined. Okay, after the formation of molecular orbitals, uh, uh, we can say that symmetry and energy will not be different. The energies and symmetry must be same for the newly formed molecular orbitals. Okay, third, atomic orbitals is monocentric while a molecular orbital is polycentric. It means, simply we can say that molecular orbitals will show the multiple centers during the formation of a molecule. Third one, number of molecular orbitals formed is equal to number of combining atomic orbitals. This concept we have studied in hybridization also. Total number of orbitals are are participating in the hybridization will produce same amount of new orbitals after the mixing of orbitals. It means participating orbitals and formed orbitals will be same. Okay, so same theory is applied here, so we should not be worried in this point. Next, bonding molecular orbitals has low energy and high stability. This is a very obvious thing. Whenever orbitals combine together, they will form BMO, bonding molecular orbital, and ABMO, anti-bonding molecular orbitals. Bonding molecular shows less energy but high stability. That's why whenever any electrons are surrounding in the atmosphere, they prefer to enter in BMO firstly, not in ABMO, because ABMO contains high amount of energy but BMO contains very less amount of energy. That's why they prefer to enter in BMO, and uh, they provide also the high stability of that molecule. Okay, and these BMO are also responsible for the formation of sigma bond and pi bond. So this is a very important thing we should know. And molecular orbitals are also classified into three types, that is sigma bond, pi bond, and delta bonds. Okay, what are delta bonds? Delta bonds are partial bonds, such as I'm giving some examples. Suppose we have CO, that is carbon monoxide, we can say rather. Okay, C double bond O, this is stable form, but due to the high electronegativity of oxygen, this type of partial bond can also be formed between carbon and oxygen. So okay, so this is sigma, this is pi, and this is delta. So delta is a false type of bond or pseudo bond, but it is present in many molecules to explain the stability of that molecule. Okay, so we have discussed many things today. uh, we have completed this flow chart. I have to tell you two things here. Just wait. Yeah. So I have some pictures here for explaining the ionic bond, chemical covalent bond, and metallic bond. So metallic bond is not important for you right now. So we'll observe ionic bond and covalent bond only. Now see here, for ionic bond I have given you the example of NaCl. Sodium has 1 electron, Cl has 7 electrons. Due to the electropositive nature of sodium, it has released 1 electron from its outermost shell and given to the chlorine. That's why they contain some charges, and due to the presence of opposite charge, they combined together and formed a solid molecule called NaCl. Okay, but in covalent bond, Covalent bond can be occurred between same or different elements. Okay, the example of same elements are hydrogen. Both H have a single bond, and after the sharing of single bond, they are forming hydrogen molecule. Same example with water. One oxygen is combining with two different hydrogens, sharing of electron like this, and water will be formed. Okay, I have one simple picture also. Yeah, you can see here some different species, or we can say atoms, and some different dots. These are not dots. This technique is called Lewis dot structure. Lewis dot structure, which says we can explain the presence of electrons in any atom or any species with the help of dot. It means Lewis assumed each electron in the form of dot. So one dot is equals to one electron. It means hydrogen contains only one electron, helium contains two electrons in its outermost shell, lithium has only one electron, sodium has only one electron. Okay, neon contains 8 electrons, that's why it is more stable. Argon contains one electron, it is more stable. They are following the octet rule we have discussed earlier. Octet rule, and we have discussed that atoms or molecules which has octet, or we can say 8 electrons in their outermost shell, they will be more stable than other elements. Okay, and fluorine has 7 electrons. Okay, so these things are very important to know the phenomena of theories and hypothesis of chapter chemical bonding. So you should learn from your own side also. If you brush up your things in deep manner, you will able to solve more questions in JEE Mains and Advanced. And chemical bonding is a very important chapter, and with the help of this chapter you can enhance your marks in the main examination, final examination. Okay, yeah, I have one more picture here. Let me small this picture, just yeah. I have added this picture in this lecture because this is example of O2 formation of O2 molecule. In O2 molecule, every oxygen contains 6 electrons in their outermost shell. 1, 2, 3, 4, 5, 6, 7, 8. Atomic number of oxygen is 8, but how many electrons in its outermost shell? So you can see here, outermost shell is this shell. Okay, so remember 1, 2, 3, 4, 5, and 6. Okay, but to stabilize itself, oxygen needs 8 electron. So it is attracting another oxygen molecule to gain these 2 electrons, because with the help of these 2 electrons, 6 electrons plus 2 electrons will be 8 electrons, and the molecule or that oxygen will be more stable than its original form. Okay, so many students asked me why atoms or elements are forming bonds, why they are forming bonds, why they are not like noble gases. So very simple, I have very simple answer for this question. That is, every atom or molecule, sorry, not molecule, every atom or species or atom or element are forming bonds to stabilize itself. If they have 8 electrons in their outermost shell, they don't need to form any kind of bond like noble gases, because they are electron sufficient molecules, sufficient atoms we can say. But except noble gases, all the elements present in the periodic table, they are not stable in the single form. So to stabilize themselves, they need to connect with other elements or other species. They either they will be similar or different, doesn't matter, but they combine with other species to make themselves stable. Okay, then the best example is oxygen. You can see on your screen. Oxygen in single oxygen is not stable because it has only 6 electrons in the outermost shell. But whenever it combines with other species and gains 2 electrons from them 8 electrons are complete, and that oxygen will be stable. Okay, one more example I need to give you, that is uh, FeCl3. Now I have a question for you. Is FeCl3 stable? Is it a stable molecule? The answer is no. It looks like stable, but it is not so stable during a reaction, because if I open the structure look like this. Okay, and if you observe the electrons of outermost shell, 1, 2, 3, 4, 5 and 6, Fe has only 6 electrons in the outermost shell. I have told you earlier, one bond is equal to 2 electrons. So we have 3 bonds, it means 3 into 2, 6 electrons. So Lewis told that a molecule is stable, a molecular atom is stable whenever it gains 8 electrons in the central atom, in the central species, but it has only 6 electrons. That's why this molecule is not so stable. That's why during any chemical reaction, FeCl3 gains electrons or combines with electron dense species. If FeCl3 observes Cl minus, FeCl3 will attach with that Cl minus and will form FeCl4 minus. It's an ionic molecule. Now Fe is stable. Now this molecule is stable because this, after the gain of 2 electrons from the Cl, it shows octet. Okay, so Lewis gave a very simple thing. If any atom or element or a molecule uh, want to become itself stable, want to stabilize itself, it has to complete the octet. So this chapter, the conclusion of this chapter is, every atom or species are making bonds to stabilize itself, and for to gain that stability, they has to combine with itself or with other different species. Okay, and this whole phenomena is called phenomena of chemical bonding. So we can say that chemical bonding is nothing but a type of attraction between two same or different molecules, same or different atoms, to make themselves stable. Okay, so I hope today's lecture was helpful for you. One or two important things, please read this chapter in a very deeper manner, because many questions have been asked in past examinations. You can observe the previous year questions also. Please solve previous year questions simultaneously after completing the chapter, because it will be beneficial for you, because in the final examination you will solve only questions, right? So please do it earliest, whenever it possible for you. And some of the important topics are very important, like types of bonding. VSEPR theory is very important, please remember that. Hybridization is very important. Similarly, MOT theory is very important. In this chapter, MOT theory is highly important. Two different we can say tables are there, diagrams are there. So please remember that, please practice that, practice questions as much as you can, because this chapter is very scoring in JEE Mains and Advanced. No numericals are there, only factual data you have to remember from your own side. So if you remember those factual data, you can solve questions easily, very easily. If you observe the questions of previous year, you can see all the questions are based on NCERT. Okay, so if you are solving NCERT questions along with the theory, you can able to score very high marks in the um, mains examination. Okay, so enough for today, guys. Thank you so much. I hope this lecture is beneficial for you, and all the very best for your future examinations. We'll meet in the next lecture. Thank you so much. Have a nice day. All the very best.